Okay, so today we're going to talk about systems of inequalities and graphing them and all that good stuff. So first things first, we have a system of inequalities where it's x minus y is less than 1 and 2x plus 3y is greater than or equal to 12. So the way you graph these, well, you graph them like you normally would any other linear equation. Imagine there's an equal sign here. So I'll pick a different color for that. I don't know, let's pick red. So imagine I have, now I imagine, okay, x minus y equals 1 and 2x plus 3y equals 12. So what do? I pick points. Well, x and y intercepts. So for this one, I know that my x-intercept is going to be the point 1, 0. And the other point is going to be 0, -1 for my y-intercept. And then here, I can do the same thing again for this one, x and y-intercept. So if x is 0, y is 4, so my y-intercept is the point 0, 4. And my x-intercept, well, would be, well, if y is 0, then x has to be 6. And now I'm going to plot the points. So I'm going to pick a different color. Let's pick green. Why not? So I have my graph. And now I'm going to plot the points. So first I'm going to plot this one. But remember, less than. So I plot the point, okay, 1, 0. Say this is 1. And the point 0, -1. This is -1. So believe it or not, when I'm plotting these, yeah, I have the points. But since it's less than, it's not a solid line. Dashed line. So this is x minus y is less than 1. Now I'm going to graph the other one. And I'm going to pick a different color that should, to be able to specify the difference between two graphs. So now this one, I have greater than or equal to. So the fact that there's an equal sign here means it's solid. But the first one, again, is a dashed line. Why? Because it's just a less than sign. There's no equal sign with it. The only way it's a solid line if there's an equal sign. If there's not an equal sign, then it's a dashed line. So plotting this to point 0, 4. 1, 2, 3, 4. And the point 6, 0. So 1, I got 2, 3, 4, 5, 6. So now I'm going to plot it, draw my line, and my lines are graphs. So this is 2x plus 3y is greater than or equal to 12. Well, now here's the part that's a little bit tricky. I have to do some shading. Now, when I do shading, the shading represents where these inequalities hold true. Well, how do I know? Well, first off, you got to pick a point where it can hold true. So for example, I can pick the point to make it really easy, the point 0, 0. So if I pick the point 0, 0 at the origin, does that satisfy both my inequalities? Well, if I plug 0 into both of these, that's 0 less than 1. That's true. If I plug it into here, this is going to be 0 plus 0, which is 0 greater than or equal to 12. No. So that means there's no shading here. So now let's pick another point. Say I do the point 2, 0. Does that hold true? 2 minus 0 is what? 2. Well, 2 is not less than 1, so that's already out. We can't have that. And you notice how I picked a point here and in here, because I want to pick points where the region's bounded by the two lines here. So the region here, here, we tried those, didn't work. Well, what about this one? Well, what about the point 5, 3, right? Because if I do the point 5, 3, this is 5, and 3 is right here. So let's see if this works. Again, I have 5 and 3 there. So if I do 5 minus 3, that gives me 2. 2 is not less than 1, so that doesn't work. So then it's going to have to be this, but just to be sure of ourselves, let's pick a point that would work. So I do the point 0, 5, right? Because 5 is right about here. So if I try this point 0, 5, the point 0, 5, right? Well, let's plug it in. 0 minus 5 is -5. Well, -5 is less than 1, so we know that works. Again, it's the point 0, 5. Let's try for the second one. Plug in 0, 5 here, I get 0 plus 15, which is 15. 15 greater than or equal to 12. Well, yeah, because 15 is bigger than 12. So that means I shade in here. So let's try another example that's a little more complicated. So suppose I have y is greater than or equal to x squared minus 4, and x minus y is greater than or equal to 2. Well, similarly, just like before, I want to graph these as if, or excuse me, I want to graph them as if, they're equal, not inequalities, to get my points and the idea where, everything occurs. So y equals x squared minus 4, and x minus y equals 2. So for this first one, x and y intercepts. Okay, well, if x is 0, y is 4. And if y is 0, well, x is plus or minus 2. So I have 2x intercepts, which makes sense because it's a second degree polynomial. So I have a maximum of 2x intercepts. I can't say no less because sometimes there's only one, but in this case, there's 2. Now here, x and y intercepts. Well, x is 0, y is -2. So my y-intercept is the point 0, -2. And if y equals 0, then x is 2. 2 minus 0 is 2. So now let's plot it. Okay, so let's see, let's plot, I don't know, let's do one in purple. So suppose, let's graph the first one. Y is greater than x squared minus 4. So, oh, I made a mistake here. That's not 0, 4, it's 0, -4. My apologies. So I plot the y-intercept. This would be the point 0, -4. And then the x-intercepts are -2, 0, and 2, 0. Now, this is a parabola, and since there's an equals here, and equal underneath, it's solid. Now, let's graph x minus y is greater than or equal to 2. And since there's an equal sign in here again, it's going to be solid. So 0, -2, so 0, -1, -2. And then I'm going to have the point 2, 0 right there. So this is the point, or excuse me, the graph x minus y is greater than or equal to 2. And this is the graph y is greater than x squared minus 4. So, well, now we got to know where the shading occurs. Well, let's see. We got to see where it holds true. So let's pick the point 0, 0. So if I plug in 0 for x and y here, this is going to be saying 0 is greater than 0 squared minus 4, which is 0 minus 4, which is -4. Well, 0 is greater than -4, so that holds true. Pick it here, 0 bigger than 2, because 0 minus 0 is 0. That's not true, so none of that can hold. So let's say now I pick well, let's pick a point outside here. Let's say I do the point -3, 0. All right, because I can go here. This is -3. So let's pick the point -3, 0. So if I pick 0 for y, that gets 0 here, -3 here. That's going to be -3 squared, which is 9. Minus 4 is 5. Well, 0 is not bigger than 5, so that can't hold. And if I try the point 30 here, well, I get the same thing because this is still going to be positive and all that, so that doesn't work. So what about, let's say we try, well, the fact that it didn't work here and it didn't work here, so these regions are out and didn't work in here. So since nothing worked here or here or here, well, then let's try in here where this region here is bounded by these two graphs. So be the point 0, -3, 0, 1, 2, -3. So let's plug it in. -3 for y, that's -3. 0 here, it's 0 squared, which is 0, minus 4 is -4. Well, -3 is bigger than -4, so that holds true. And we plug in 0 here, you have 0, and then -3 here, 0 minus, so yeah, 0 minus -3, which is just 3, which is bigger than 2. So that holds true. So that means this is the region where we shade. And again, where we shade is very important because this is where, this tells us the solution to the system. So any values within this shaded region is a solution to this system because it satisfies this. And that's it. So I hope you enjoyed the video. Have a great day, everybody, and see you all next time. Bye-bye.